The growing popularity of models like GPT has opened up possibilities for leveraging them in larger document repositories. But how can we overcome the limitation of token size and ensure answers provided are accurate? This talk will explain possible solutions to address these limitations. Our speaker has 25 years of experience in IT and has mastered the art of software development. Please welcome the Managing Director of Monstar Lab Philippines, Mr. Alan Tan.
And a pleasant morning, everyone. I am ecstatic to be here, especially at the opening session of this year's SoftCon. Very excited to share about some of the knowledge I have about GPT. I hope you all had your breakfast because this topic is going to get technical. I actually designed this topic more for programmers, so I hope for the developers out there, you'll be able to pick something up about extending GPT and large language models. As also known as ChatGPT. GPT is more popularly known as ChatGPT. So as this has taken a huge hit starting early this year. So you might as well join the bandwagon and talk about this. But before we start, I'd like to ask everyone to please go to the polls and answer the only question I have, just so we get an idea about the level of proficiency you have. And just so we get I know how to level up with regards to the topic that we are gonna talk about for today. All right, so let's give a few more seconds for people to answer the poll. Wow, we have so many attendees for today. Excited to share my knowledge. Let's give it 5 more seconds. Please go to the polls and answer the poll. And I guess we can already start showing the answer because we already getting a pattern already on the number of on the number. So just for everyone's appreciation, more than 80% are already using ChatGPT from this. I guess because this is an software industry topic, no. So I presume many are already familiar with ChatGPT, and but very few are still using the programming long chain, and that's what we're gonna talk about. So for those programmers out there, stick around, and we'll go through some coding using long chain, some core concepts about large language models, embeddings, tokens, so you get to know how you can possibly incorporate large language models into your project. Okay, the poll has now been closed to get an idea about the population that we have for today's session. All right, so let's get the ball rolling. Now, this topic has been, I guess, difficult for me because I submitted the presentation about around April. That's about 5 months ago. And the problem at the time of large language model is the token size. The token size of GPT-4 is limited to 4,000. And when we're trying to use the library, when you send in a large document, it restricts that to 4,000. So we started looking for different ways to go around the limitation. So I thought, this is going to be a good topic to talk about. And 5 months has passed since, and the technology behind GPT has progressed so much. It really moves very fast. Now I felt like the topic is now obsolete. So I actually have to rewrite some of the topics, some of the slides and the actual hands-on, so that I get at least a bit updated. You get outdated already in just 5 months. That's how fast this language or this technology is moving. So, but nevertheless, the concepts I think would still be applicable. They're still the same, except there's a lot of libraries being built on top already, which makes it much easier for developers to write large language models. So, ayun. So before we start, a bit about what we're gonna talk about. I'll just go through the history. Because of my age, I just want to share about the history of GPT, how it started, about then we talk about the transformer models, the architecture behind the large language model, some of the architectures that you can create so that you can create your own large language model. And then lastly, we'll go to the hands-on. So this is gonna get hairy. especially for the non-developers, because we will go through the actual code. No, for the developers, this is gonna be exciting. No, kasi you see actual Python codes using libraries LangChain and Streamlit. Okay, so just a bit about the history. The concept behind large language model, actually, if you look back, no, it dates back to 60s, very early stage, and because it's also form of neural network. No? So whatever is the design of neural networks way back then, technically, that's where the GPT is an evolution of GPT. I remember the very first AI, the very first earlier sessions of AI about POS tagger, parts of speech tagger by Christopher Manning, talks about how they develop algorithm for defining part of speech by recognizing characters, character by character, and understanding the sequence of character. Like if the word Q, most likely the next word of Q is actually letter U, right? And if you combine all the different words and the sequence of the characters, they are able to reach about 90% accuracy what parts of a speech, a certain, whether it's a noun, a pronoun, or a verb, So they use that, the predicting of sequence of characters to define POS tagger. And surprisingly, it's the same concept that the transformer model is doing. It is merely predicting the next word, out of a sentence. Of course, there's a lot of changes, but the concept behind is the same. So that's still applicable until now. The main difference is, of course, there's larger set of data available in the internet. GPT runs on trillions of words and then billions of parameters. That's why it's able to build concepts behind it. No, but really, what it's doing is just predicting the most likely next word. No? Then in 2017, the team of Google, they developed the transformer model. No, this is actually open source. Attention is all you need. That's a paper about it, in 2017, and that's also when OpenAI started in 2018. And then in 2022, they released the Chat GPT, which combines the trillions and trillions of data and then billions of parameters to come up with a large neural network that we are using now, in ChatGPT. So that's a bit about brief history about it. But essentially, in the high level, if you look at it, this is what it does. No? We've seen this in Google. What is the weather? It just predicts the next word. The main difference, of course, is that the Google algorithm runs on a recurrent neural network, which is essentially process the words sequentially. No? So with transformers, it's able to process the words in parallel, simultaneously, different locations in the sentence or in the sequence of words. No? So, but behind it, that's what it does. No? So if you look at this slide here, basically it's saying everything is data driven. It's just, they're all numbers. All the words here are just represented by numbers. The cat sat on the mat. Now, what's the most likely word? Whether it's sat or sad, there's a probability, right? Out of all the sentences you've seen, what is the most likely that it's a sat or it's a sad word? No? And same with high wind tonight, large. So it's all just numbers behind the scenes. A large, large set of numbers. No? And but if you actually look at it, language is complex, right? It's not. That's why it took some time for GPT to be realized, because it's not that easy. Also, for example, happy not sad, sad not happy. If you look at the words, it's the same set of words. So if you look at the probability, they probably have the same probability. But if you look at the context, they're totally opposite. No, same goes with the word down here. The bank interest increased this year, and I have no interest in buying the car. The word interest will have different meaning based on the context that you are using it in the sentence. No? And possibly it's in one sentence. No, I have no interest in buying a new car, because the interest rate is high. Right? So the word interest is used in the same sentence, but in a totally different context. No? So that's the problem with the previous algorithm about predicting or neural network. No? Which is why the transformer model was designed. So the transformer model solves this issue on a few. There are three key important aspects. No? One is positional encoding. No? So the positional encoding basically is saying na it's able to identify the order of the words. 1, 2, 3, 4, 5. No? So the different ordering of words will have different meaning. So they take that as a consideration. There's what they call as the attention, no? So which I'll explain a bit later. But basically, in a sentence, it puts attention in some parts of the word that is more important. That puts context, that gives context to that sentence. And then multi-headed. So the multi-headed allows us to run sequence the operations in parallel. No? Kasi nga, it's possible that the context is at the later part of the sentence and not necessarily in the earlier part of the sentence. So in this slide, we'll see how attention is being used. No? So the word interest, if you look at the sentence up here, I have no interest in buying your car. The interest is more related to a car, diba? Or buying your car. No? The interest down here is more related to the bank. No? So the attention in the transformer model puts priority to the other words that is that it finds relevant. No? So in this case, it gets to the context na the interest that you are referring to in this sentence down here, in bank interest, is most likely referring to interest sa bank when you get a loan, right? And the interest up there is your personal interest in buying the car because there's the word buying and there's a car. So that's what the attention is able to add into the algorithm, so that GPT is now able to get better context of what the sentence is talking about. All right. So again, that's what the transformer model is about. We don't need to understand the diagram anymore. No, that's for the PhD. But what's important is for us to understand is that the advantage of the GPT architecture is able to understand the order, the sequence of the words and where they are positioned because they have different meanings. It's able to put attention in certain words so that it understands the context, and it's able to run in parallel. That's why NVIDIA now is very popular because it can run everything in parallel and perform faster. No? Kasi if you run in sequence, it takes a while for processing to finish. So that's for the attention. Next is tokens. So it's important because even the large language models now, if you use ChatGPT, is still limited in number of tokens. And if we are processing large number of documents, for example, corporate documents, you want to index all of them, GPT will charge you per token, right? So at least we get an idea how token is being counted. No? So token, more or less, is basically a word, but not necessarily one word, one token. There are certain words that are split into multiple tokens. No? So you can see from this diagram here, or from the image here, like the word revolution is divided into 2 tokens. How it does that, I don't know anymore, but there's a library where you'll be able to extract the tokens when you feed it with a sentence. No? So there's a standard library also that OpenAI is using that we can use so that we know how many tokens a certain set of words or certain set of documents that we are feeding to OpenAI. This was important way back because, as mentioned, ChatGPT 3.5 is limited to 4K tokens. No? So it's only 4,000 tokens. So you need to know whether you're going to exceed the 4,000. If you're going to exceed, you need to split it or do something so that it would fit inside the limitation. So that's for the tokens. The next is about embeddings. So for each word, the large language models translate every word into embeddings. The embeddings are numerical representation of the words. And if you can look at this diagram, this is a 2-dimension only. No? If you look at the diagram here, the purple are all words related to religion. Diba? So, and then the red ones are more into space, right? And then the blue one on top would refer more on technology. Now, so that it's able to segregate words into their context. No? Now, this is a 2-dimensional. So I hope that the diagram, you get a picture how it's able to put some level of context into the words, no, by segregating different words. No? So now the thing is, this is only two-dimensional. No? The GPT runs this in multi-dimensional. So imagine you add another dimension on that, another dimension. No? So it adds additional graphs, or yung mga nodes, no, in another dimension. And imagine there's like 1 billion dimensions. So there's 1 billion of that. So technically, if you look at the GPT, it says 7 billion. More or less, it refers to the number of dimensions that it's able to predict. It's able to model. So that it's able to get the proper context of each word, because the word gas may have different meaning depending on where it belongs to. No, so that's what embedding is about. No, at least if we can at least visualize, how the words are scattered in a multi-dimension. It's gonna be hard to visualize, syempre. But that's why we're plotting it in 2D so that we get an idea, you know, what embedding is about. Now, embedding is a sequence of numbers. It's just a vector of numbers that represents a sequence of words or numbers, or the sentence or the word itself. No? So it's a numerical representation inside the model. Okay, so I think we can stop there, then we can continue how that works. Now, what's important is that when you send a sentence or question to GPT, it translates that into an embedding. The embedding is a representation of that sentence in the model, and then it will try to find the closest answer within that dimension. So, for example, if you send the word Christ, diba, it sees it here, so it will most likely search only within the parameters near the word Christ in the two dimension, but it's multi-dimension. So that's what embedding is about. And the other thing to understand is that there are two main process that is being performed: training and inference. So training would refer to what we create the model, right? So you have raw data, trillions and trillions of words. It undergo pre-training. After the pre-training, what you have are embeddings of this large. That's what the model is about, diba? There's GPT 3.5. It's a model with 175 billion parameters. The GPT-4, they say, is about 1 trillion parameters already. No? So that's what training is about. And this is expensive. Creating our own, models, training our own models is very, very expensive. I heard it's close to like $10 million. No? So it takes a long time and a lot of CPU, a lot of power to actually do this. No? So that's why we are only using existing models already. And then you do the inference from the existing model. So when there's a question being asked, you get the embeddings from the model, and then you generate the response. So there are two steps being performed here: the training and the inference. Now, there are different approaches that you can take when you want to, fine-tune or improve your own large language model. The easiest to understand is, of course, prompt engineering. For all ChatGPT users, you are doing some form of prompt engineering because you're probably asking questions. If the answer is not right, you can rephrase the question. If the answer is wrong, you can tell them they're wrong. It will correct its answer, right? So depending on how you write the question, the prompt, it will reply accordingly. No, so that's one way, and that's probably the easiest way to do a large language model. No, is by playing around with different prompts. Now, next is the retrieval augmented generation, which is what I'm gonna talk about hands-on for this session. How to do retrieval augmented generation. So basically, what this does is it does a search muna. So for example, you have a large set of documents. It performs a search. What are the relevant sentences or sequence of words that is relevant to your question? It filters that, and then it generates an answer based on that. So it retrieves, and then there's an augmented generation of answer. There's supervised fine-tuning. So in this case, it's more hardcore because you actually have to fine-tune the model. No? So GPT has existing base model, and then you add your own corpus, you add your own instructions, and then it improves the response. Now, so for example, if you are in I think that's what Bloomberg did, di ba? Bloomberg has a large set of documents, financial documents. They feed it to an existing base model. So they created a Bloomberg GPT. No? So, and then there's reinforced learning from human feedback. Basically, you have humans responding, and then the response is being converted into rewards so that the model will improve. And then recursive siya. No, it continuously learn and improve. Okay, now just for information of everyone, in terms of accuracy, there's a study made with regards to the accuracy. If you look at GPT-3, so this is humans actually rating the response. Now, if you use GPT-3 as a base, no, the response is not really good. I think it's around GPT 3.5 that ChatGPT has improved, where it started to make more sense. No, but yeah, then when you add prompting to GPT, you'll see that the response is much better, meaning less toxic and more accurate, less hallucination. As you've heard, like GPT is very prone to hallucination. It makes up the answer with confidence, and you think it's correct, but it's actually wrong. No? Then you can play around with different prompts so that it improves. Then there's GPT-3 plus fine tuning, and then the accuracy increases further. So what this graph is saying is that the model size actually is not much of a factor anymore, right? If you look at the number of parameters here, 1.3 billion, 6 billion, and 7 billion. No, even with 175 billion, if you're just using GPT-3, but you're not fine-tuning it, you're not giving it feedback, it will not generate more results. That's why Sam Altman mentioned, like, GPT-4 will probably not exceed the number of parameters anymore, because the more data you provide it, the more hallucinations it can generate. No? So there's probably enough data already. It's a matter of fine-tuning the data, how it's being used to improve the accuracy of the response. And they say na ChatGPT-4 now has less hallucinations now. And that's a lot of researchers are working towards improving that. I don't think it's there yet, no, but hopefully we'll get there. And I think that's my interest also, like trying to find out new ways how we can improve this and actually use this in production. All right. Now, I don't have much time left. Now, with regards to retrieval augmented generation, basically what we're doing is we have large documents. Now, what we have are corporate documents, large documents. We process them, right, and put that into an embedding, our own embedding database. No? So, in our hands-on, we will be handling vector database. And then we store the embeddings into a vector database. The reason why we are using vector database is that it's faster to search embeddings to find similarity on set of numbers. So it's not the traditional Oracle or MongoDB database. So they will be very slow if you're gonna search embeddings because there's a different mathematical algorithm to find similarity in embeddings. And vector DB is designed to do the search much faster. So once you have your own custom embedding database, when a user sends a query, you do a similarity search. What are the phrases that are similar to the question that is being asked? Now, once you have the result, you get the retrieved context that is then being passed for inference so that the large language model can generate a more relevant answer. And the advantage of that is that aside from giving a more relevant answer, it can also show you the sources. What are the actual phrases that was used to generate this answer? So you can cite sources when you do retrieval augmented generation. And so for the rest of the session, I'll be showing you a video. I did a video so that I don't make mistake while doing the hands-on exercise about how to use LangChain and Streamlit to actually do your own RAG, retrieval augmented generation. So without further ado, Let's get into action. We are also running out of time. Um, Technical, please play the video. Video, please. All right. Okay. So now we're gonna do our hands-on using long chain libraries and different tools to create your own LLM application. So we're gonna have some fun for all the geeks out there. And of course, naturally, we're gonna start off with our IDE, opening our Visual Studio code. So let me just open my Visual Studio. Okay, I have Visual Studio open here. I already have an existing folder called Softcon. So that's where our project will be for the rest of this session. Okay, now the first thing we need to do is to actually create an environment, using Python environment. So we'll just use this Python command to create a new environment so that we can start clean from scratch and then start our integration. So that will create your some environment configuration and start with a clean um, environment for your Python. So we're gonna install our libraries using pip install. Of course, we're gonna need OpenAI. We're gonna need LangChain. We're gonna use LangChain for this demo. And we're also going to use our vector database. In this case, we are going to use FIS, which is an in-memory vector database, which is pretty good for demo purposes or for experimentation purposes. There are a lot of vector database, Milvus, Pinecone, which actually store this into permanent databases. But for FIS, this is in-memory only. So for purposes of demo, it should be enough. And then we're gonna play around with token lengths also. So you get an idea how tokens are being counted by OpenAI. Because as you know, when you send requests to these LLM APIs, they count through the number of tokens. So we're gonna use tick token and just Python environment so that we can secure our OpenAI API key. Okay, so now it installs all the library. It may take a while in your case. I have pre-installed all this library. So now these libraries are already included in my environment. So the first thing you need to do to start your LLM, or the next thing you need to do to start your LLM integration, is to to get your API keys. Now, your API keys, you can retrieve that from, by going to your OpenAI account and view API keys. In here, you'll be able to see your API key. So I already have created mine for Softcon. You can create new libraries if needed. All right. So once you have your OpenAI keys, you will need to create a environment variable. Your environment variable, so that in here, so that it will contain your API key. The purpose of putting the API key in your environment variable is that you are not supposed to push your secret keys into your repository. So that DNV it can be automatically ignored. So you just use OpenAPI key and then you put your keys in here like that. Now I'm not gonna show my secret key, so I already have the file somewhere, so I'll just copy my environment file. Okay, so the next step is to actually start with our first program. All right, so for the first program, I'm going to show you how token lengths are being counted using tick token. So this is a very useful tool if you want to know how many tokens is being sent. So the first problem you'll encounter when you send a large set of data is that
OpenAI, limits the total number of tokens. So you might want to know how many tokens is actually being sent so that you know how much you need to send so that you don't get an error when you're sending tokens to OpenAI. Now, the standard or the default token length counter or parser of OpenAI is tick token, which is what we just installed earlier. So we're going to import tick token, and we're going to use the tick token library to create to count the number of tokens for the data that we'll send. So we're gonna use the main. And okay, so the first thing we need to do is to set up our environment variable. No? So we're gonna use the .env um, there, and we're gonna load our environment variable. So this automatically loads um, the OpenAI secret keys, so that if we're gonna use OpenAI secret keys, it will automatically retrieve the data, the secret keys from your environment files. No? So the first thing we need to do is to tell tick token what encoding we want to use. Now the default encoding of tick token for GPT 3.5, sorry, and 4 is the CL100. Okay, so we're gonna use get encoding. You put here CL. You can find this in the documentation. No? So this is the encoding. Sorry, this is the encoding that we use for GPT 3.5. Diba? And then we're gonna put in some text, no, that we want to count. So this is an example of a long text, which I retrieved from the Constitution. According to Microsoft Word, this has 95 words. No? So we want to know, when we send 95 words to OpenAI, how many tokens will it convert to? So that's our initial goal. Okay, so we're going to use the encoding that encode long text. No? So this will actually return a series of encoded numbers that represent the words in token format. And then let's try to print. Let's not print the encoded values. These are numbers instead. No? So instead, let's count how many tokens will this convert to. No? So the text here is actually 75 words. And then if we try to run this tool, it returns 95. So basically, you send out 75 words from Word, and of course, it tokenizes the word. You get the result of 95, sorry. So now you have a better idea. Now, how many tokens are you actually going to send? Now, so if you're sending a very large text, you can create your own algorithms to actually split this text so that it would fit the limit of OpenAI. For GPT-3, I think it's 4K tokens. So you want to limit it to a series of 4K tokens so that the API will still respond to your request. Now, because we are using LangChain, LangChain has several libraries already that helps us split text, which has been very useful depending how you want to split it. So you can also split it by token. So one way is to use the token text splitter of LangChain. So we're going to use that in this case. So to be able to use that, we would first need to import it from LangChain that text splitter. So we're gonna use the token text splitter of LangChain in this case, and we're gonna instantiate it, right? So to instantiate it, we use here text splitter that token text splitter, but token equals to, and then token text splitter, we then indicate the number of token, which is the chunk size, and the chunk overlap, which is the number of words, the number of overlap when you split a text. So let me just explain that a bit. Okay, so in this case, we will use overlap of 0. So what happens with the chunk size is that it will limit the text inside to 10 tokens. So it's assuming this is your 10 tokens up to here, right? So it will split it there. When you put your chunk overlap, it will get X number of tokens from the previous text. It's simply put in 5. No? So if this is your text, this is your first 10 tokens, for example, no? And you put in 5, it will include probably, the first 5 in the previous text so that there is an overlap between the first and the second chunks, right? So we have the text splitter, then we'll do the chunks to actually split the words, text and that split text, long text. Then let's print. Yeah, let's just print the total number of chunks. How many chunks is sorry. How many chunks is generated from here? And then let's also print the um, the actual content of each chunk. So I'm gonna put 4 chunks C, and then let's print C, and then let's print yeah, 5, so we can how to split this. All right, so let's try to run this. So basically what we did is we used the token text splitter to split this text. Yeah, we sovereign people. Oh yeah, so you'll see now that it actually splits this long text into a series of chunks. We, the sovereign people, have sovereign Filipino people, imploring the aid Almighty. And if we convert, right, so it continues on right exactly where it ends. So that's for the token text splitter. Now there are a lot of libraries from LangChain that allows you to split text. It can be by character, and we'll probably use a couple more for the rest of this session. But the third thing I want to show you is actually to retrieve the embedding. So we've touched about how tokens being counted. We touched about the libraries that you can use to split tokens. And then the third is how to retrieve the embeddings. No? So we're going to use the same set of text, and then we will retrieve the embeddings of this text, using the OpenAI embedding. Okay, so let's just actually I think we don't need to print this anymore. Let's just remove this. So just to clean up the text. So we're gonna use the chunks to pass into the OpenAI library to retrieve the embeddings of each chunk. So we have the embeddings. So we first need to instantiate the OpenAI embeddings. Okay, so OpenAI embeddings. We need to include that also from LangChain.embeddings, import OpenAI embeddings. So now we have imported that. And we have the OpenAI embeddings. Then we will call the embeddings model. Is this correct? Yeah, it looks no, it's wrong. So that's the that's Microsoft Copilot. I think primarily because the libraries of OpenAI is pretty new, so it's not able to suggest very accurately. But what I want to use is the embed documents of the embeddings model. So we pass the chunks. And then let's store this in the embeddings. And then let's print so that we get the next. Okay, now that we have the embeddings, let's just try to print. So because we pass the different set of chunks, and then we'll try to print the corresponding embeddings, the first embedding of the first chunk. So let's try to run that, and then we will see the embedding, the corresponding embedding. Now that's pretty long, so let's just print the chunk. Yeah, we the sovereign people, that's the chunk 0, and then the corresponding embeddings of that, is a series of numbers. Actually, you have to print that. It's, these numbers. No? So that's how you can retrieve the embeddings. Now, the embeddings are the ones actually being stored in a vector database. No? So this is a vector, right? If you notice, this is a vector. It's an array of numbers. And the advantage, of using a vector database, it can search through a large vector database pretty fast. So that's the purpose why there are vector databases in large language models. So now that we have done the tokens, we've done the splitting, we've done the embeddings, we'll then start off with creating the vector database. So again, LangChain already has the libraries to integrate with vector databases. So in our case, as mentioned earlier, we're using FICE database. So we're going to create a save, save the text into a FICE database. Now we for purpose of this demo, I already have a complete text, well, not really complete text, the first portion of the constitution in a text file. So this is a longer set of text, and we're gonna read the content in this and then save it into the vector database. So it's in constitution.txt. Okay, so the first thing we need to do is, of course, to replace the long text with the text here in this text file. Okay, so we're gonna first create a method to read the file. Read and read file. Okay, for those commands, Copilot is kind of useful because it already returns the correct command I want to do. So, and then we're gonna replace this long text with read file constitution. Okay, so now we have, the first part, the initial part of constitution in our long text, and then we can do, you know, saving this embeddings, the embeddings of this text into our FICE database. In this case, we're not gonna use these libraries anymore. In fact, we're just, yeah, we don't need any of this. No? So we'll use a different library of OpenAI to parse the text and to convert it into their corresponding embeddings. No? So we're going to use, so the first thing we need to do when we read a long text is actually to split it into smaller chunks. No? So in this case, we're going to use recursive, we're going to use recursive character text splitter. So recursive text splitter. And similarly, we're gonna use a chunk size. Let's use 500. Bam. And then we're gonna use a chunk overlap. In this case, because it's a character, no? So it's actually counting by characters, not by tokens. Okay, now what's cool, what I like about recursive character is that you can use separators. You can indicate a series, an array of separators. So what this does is that it will actually try to first look for there, 2 new lines. It will try to split by 2 new lines, and then it will split by new line, and then yeah, you can split by dot sign, or you can split by space. And then lastly, if there's nothing to split, then no need to split. Okay, so I chose this splitter because if you look at the text, these are separated by 2 lines. Actually, a lot of them are split by 2 lines already. So you'll get a more accurate chunking of your content. So that's I guess preference. So and then we'll use the chunks similarly. Chunks, we're going to get the text splitter and actually split this. Yeah. So now you have the chunks, and then we will pass this set of chunks into the um open AI into the FICE database. Sorry. So then we have yeah, this is actually correct, OpenAI embedding. So we're gonna initialize the OpenAI embeddings, and then we will use FICE to get the vector store. So to use FICE, we just, of course, we need to import FICE first. So from lang chain dot vector store, import FICE. We're gonna use the FICE library, and then we're gonna use FICE dot from text. That's the command. So this will return the vector store of the text that you will be providing. Text is equal to chunks, and then you then specify the embeddings. Embeddings, yes, that's correct. So and then you save this into a vector store. So now remember earlier when we did the embeddings, this one is actually doing the same, except it's storing it already in a FICE database, no? And you can actually use the vector store to perform a query, a search, no? So in this case, we would like to do a search, no? So it returns already the vector store, which is essentially a list of vectors. And then we're gonna search inside the different vector store. So there's a tool or method called similarity search. Okay, so you can do a vector search, similarity search. It will search the similar content, similar content based on your query. No? So let's call it a query. So let's say your query. Okay, so since this is a constitution, we're gonna put what is the prime duty of the government there. And then we then return the result. We're gonna use the vector store dot similarity search. So this will do a similarity search from the vector store given your query. So k equals 5 means it will return 5 records. So default is, I believe, 4. So we don't need to indicate that anymore. Actually, we don't need to indicate that also. So this will return the documents, and then let's just try to print the matching documents from the search results. Okay, so that returns the first 4 arrays. So it will do long chain dot vector store import FICE. Sorry, it should be vector stores. Okay. Okay. Oh, we did not import the recursive character text splitter. Let's replace this now with the recursive character text splitter. Okay. And okay. So now there's a lot of syntax error. So again, I think it's a copilot's problem. So it's from text. So there is no from text also. Should be from text. No? So sorry. Ba yan? Yan, tunay na to. Missing a lot of the plural form, and then this should be singular. That's kind of confusing. Anyway, let's get that running. So it takes a while to actually run that. So if you'll notice what happened here. So it's actually able to do a search, right? So we displayed how many results are there. There are 4 results, and it returned this as our first content, the prime duty of, and then, it returned a bunch of other matching um, similar search. No? So it probably does it's not only a keyword search. No? So if you notice, it's not necessarily only the keywords, it's also the different um, synonyms. No? So try to search because it's doing the search on the vector database. No? So what happens is that what we did is that we use the vector store, right? We do a search on the vector store. No? So now we can use the result of these vectors and send it to our LLM so that it will generate the actual a more matching result. No? So the advantage of, because if we actually remember that if we actually send the entire document, the OpenAI will not allow us. We are very limited to the number of text that it can support. So if you actually do a pre-processing by filtering the steps here, by filtering the content here, and send this result instead, then you will get a more fine-tuned search, and then it will return a more relevant result. So now that we have split, or we already filtered the content, we want to use this as to answer our Q&A, right? So instead of doing a similar search, we're going to use the Q&A chain of LangChain. So the Q&A chain will actually um, return the answer to your question, because what we did earlier is just a search, right? So it returns the exact text of, that is being searched. But this time, what we want is to actually come up with the response, okay, from our question. So what is the prime duty of the government? So we're gonna replace this text and use the vector store again, but this time we're gonna use the vector store, the QA chain of LangChain. So we're gonna get the retriever first using so this is the format to retrieve. So we're using the similarity search type, and then um, search the total number of arguments. K equals to K 4. Okay, and then you'll have our QA retrieval. We're gonna use the retrieval QA from chain type, which is our chain up there. We're gonna pass the LLM first. So we're gonna just instantiate a new chat open AI. We're gonna use the chain type stuff. And use the retriever we created earlier. And return source, there's a parameter return source document. Let's put this as true. So that, we know. Okay, so the retriever is missing. So that's a retriever going back there. We don't have OpenAI, we don't have retrieval QA. So let's import that first from For open long chain dot long chain dot change import retrieval and from long chain the chat models import chat OpenAI. Right. So now, what we did, we still use the same, I don't know, we have used the similarity search and then to retrieve the content, and then, we use the retrieval QA chain to answer the question. Okay, sorry, we have to do the query first. So we'll then have the response, um, QA, yep, QA, and then we pass our query. So then we can print our response. Let's see how that works. In this case, we're using the library of LangChain. It returned, wait, a very long text, but basically the result is this. So it returned an object that contains a query, which is what we said. And then the result is the prime duty of the government is to protect the people. And then it also incorporated the source. What are the different sources that are being used to retrieve the memories. So to retrieve the results. Sorry. So these are the different, I guess, basic or core libraries that you'll be needing to create your LLM library. So we created about the tokens, the splitting, the embeddings, the vector database, and the conversation. So technically, this is pretty much what a the core of a retrieval augmented generation library looks like. Now, in the interest of time, I'll show you a text. Sorry. I'll show you a code that has a UI, no, using Streamlit UI. Okay, so now because we don't have much time to actually go through the code, I'll just copy and paste the working code, and then quickly show you the different components of it. So we are using Streamlit in this library. You have rugui.python. Okay, now I'm just gonna copy and paste the existing code here because we don't have much time. Okay, so where is it? So we have the rug UI. So this actually contains a lot of the previous code also that I showed you. But the main difference is we are not using the retrieval QA chain. Instead, we're using the conversation retrieval chain. So it keeps track of the conversation. No, but it's basically the same conversation retrieval chain, and then it saves it into the memory. Now you might want to consider using Streamlit as your UI also when you create, especially for prototype because it's very fast to create a UI. So imagine this is a 76 line of code, and yet we'll be able to create a web interface already. So maybe I'll just show you what it looks like. Streamlit. Now, so to run the Streamlit app, you have to invoke it via Streamlit run rugui.python. Yan. So this is the interface that was created, a chat about Philippine Constitution, and then what is your question. So before we go through what the function looks like, I'd like to quickly go through the code that is in here. So you get the chat conversation chain. So maybe we'll just start off with how the UI is being generated. So Streamlit has a session, so you can keep track of the session. So basically what I did here is that if there's no session yet, right, we initialize. No? So this is the same. No? We read the constitution file, we split the text using recursive character text splitter, use the OpenAI, you get the vector store. We did this earlier, diba? So now that you have the vector store, we store the vector store in the conversation, in the session, in the session state the conversation so that we can use it later when the user inputs on the text field. Okay, so and then this is the portion where the UI is being generated. So we set about the page title, and then we write about the header, chat about Philippine Constitution books. That's this one. No? And then we display text input. What is your question? So that's for that. No? And then if there is an input on text question, you go to the method handle user input. What we do in handle user input is that we retrieve we call the conversation, right? The one we invoked earlier. Pass in the question, which is the question you type in the input field, and you get the response. And then you get the response, you save the response in the chat history. This will then render the history in your UI. So if you type here, what is the duty of the government? It will perform what is due to the government. The duty of the government is to serve and protect the people. And then so you can ask, what is the relationship of the church and government? So this will then be like chat conversation. It keeps track of the history. And the relationship with church is that it should be separated, inviolable, blah, 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 blah. So which is the result from the text, the constitution that we actually provided. And so that's pretty much it from our hands-on exercise. I hope you're able to get the gist of the topic I was, like to talk about. A few points that I'd like you to, take away from here is that it's relatively easy if you understand the LLM is relatively easy if you understand the core concepts behind it, and then you can use Streamlit, right, to create your prototype. Of course, if you're going to move to production, I would suggest you go for the full enterprise, platform, React, um, those kind of or Node.js or Python backend. But Streamlit, you're able to create your application much faster. So if you're only doing prototyping, Streamlit would be a very good tool, to help you go through your coding. So now I'm open to questions. I'd be happy to answer questions. Stop sharing and thank you. All right. I think that's the end. We're a bit overdue. But I try to answer as much as I can in the in
Yes, sir.
the chat.
Thank you
And
so
that
much,
ends the
Sir Alan.
session.
There was actually another question that was posted just now, if you'd like to answer that one. Do you still validate the accuracy of the response of the AI before returning a response to the
Yeah, so
user?
that can be an additional step. So once it returns the reply, you can put additional questions to validate but the libraries doesn't include it. So usually you just devise your own way to verify the accuracy. There are studies about that. I can't recall at the top of my head. You can do a research how the responses are being validated to reduce the hallucinations. And the report is um, promising, I should say.
There's an interesting question, Sir Alan. Would you care answering one more?
Yeah, sure, why not?
Can you share your views about LangChain agents?
Agents haven't tried. I don't know about that.
Haven't tried. There, that's actually from Nico. So Nico, I guess further research would is required for answering such question. And is there a way we can have a copy of your sample code,
Oo nga,
sir?
I'm trying to
All of
upload
them
to
are
GitHub.
asking.
So nag-sign in pa sa GitHub eh.
I'll probably just
Okay.
share it. Is
I
there a
guess
way
we
to
can share
share
with
it
the recipients.
later?
Yeah, yes, sir. We can
Yeah,
do
so we'll
that.
just
So
share it
yeah,
later.
I guess there's a lot more questions that would like to that they wanted to ask you, even from Rafael. But guys, please don't worry. You can always catch up with Sir Alan at the lounge or anywhere. You can also just message him if you have any further questions, or meet with him at the lounge table, right? So Sir Alan will be taking
Virtually, no?
virtually, of course, not there.
But
Just
I'll be in SMX on Friday. Say hi to me.
yes, that's true. He's also at SMX on Friday, so you can always pag nakita niyo siya sa SMX, don't be shy to approach Sir Alan. But yeah, we'll be taking a very quick photo op lang, Sir Alan, for as a
Sure.
remembrance. So I'll be
Seryoso ba?
yes, sir. I'll
Okay.
be turning my camera off. Let's take the photo in.
Tagal na photo yan, ah. Ano nangyayari? Okay na ba?
Okay na po. Thank you so much.
Alright.
So I hope everyone really learned so much from this session. So if you really like this session, please keep on sending the hearts and like emojis out there.
Yes, I hope
And
I didn't
thank
bore
you.
you kasi maraming hands-on.
Thank you so much, Sir Alan, for sharing your knowledge and for answering the questions of our delegates. Now, again, in case you guys still have a question, feel free to reach out to Sir Alan. And that's all the time that we have for this session. So, again, let's thank Sir Alan by clicking on the emojis, on the heart and clapping emojis. Thank you so much, Sir
Thank you.
Alan, and
Thank you all
everyone.
for staying on the session.
See you in the next one.
Alright, bye.
Bye.
Okay na.